Welcome to Falcon TV. Subscribe to the channel to stay informed and inspire us.
A black hole is a very mysterious object in space that has such a strong gravity that nothing can escape from it, not even light. Black holes are formed when very massive stars collapse at the end of their life cycle, or when a large amount of matter is squeezed into a very small space. There are different types of black holes, depending on their size and mass. The smallest ones are called primordial black holes, and they may have been created in the early universe. They are as small as an atom, but have the mass of a mountain. The most common ones are called stellar black holes, and they have the mass of up to 20 times that of our Sun. They are usually found in the remnants of exploded stars, called supernovas. The largest ones are called supermassive black holes, and they have the mass of millions or billions of suns. They are usually found in the centers of galaxies, and they may have a big influence on the formation and evolution of stars and planets around them. Black holes are very hard to detect, because they do not emit any light. However, scientists can observe their effects on the surrounding matter and radiation. For example, when a black hole is close to another star, it can pull gas and dust from the star and form a disk around it. This disk is very hot and bright, and it emits high-energy light, such as X-rays and gamma rays. This is how scientists discovered the first black hole, called Cygnus X1, in 197,112. Another way to observe black holes is to look at how they bend the light from distant objects behind them. This is called gravitational lensing, and it creates a distorted or magnified image of the background object. Scientists can also use special instruments to detect gravitational waves, which are ripples in spacetime caused by the movement or collision of massive objects, such as black holes. Gravitational waves were first detected in 2015 by the LIGO experiment, which confirmed one of the predictions of Albert Einstein's theory of general relativity. Black holes are very fascinating and mysterious phenomena that challenge our understanding of physics and reality. They may hold the secrets of the origin and fate of the universe, as well as the nature of space and time itself. Scientists are still exploring and learning more about these amazing cosmic objects every day. Black holes are very fascinating and mysterious objects that have a profound effect on time and space. According to the theory of general relativity, black holes are regions of spacetime where the gravity is so strong that nothing can escape, not even light. The boundary of a black hole, where the escape velocity equals the speed of light, is called the event horizon. Inside the event horizon, the laws of physics as we know them break down and the spacetime curvature becomes infinite. One of the effects of black holes on time and space is called gravitational time dilation. This means that time runs slower near a black hole than far away from it. This is because the gravity of the black hole curves spacetime in a way that affects all measurements of time and space near the black hole. For example, if you were to watch a clock falling into a black hole, you would see it ticking slower and slower as it approaches the event horizon, until it appears to freeze at the edge. However, for the clock itself, nothing unusual would happen and it would continue to tick normally until it reaches the singularity at the center of the black hole. Another effect of black holes on time and space is called gravitational lensing. This means that light or other radiation passing near a black hole is bent by the curvature of spacetime. This can create distorted or magnified images of distant objects behind the black hole, such as stars or galaxies. Gravitational lensing can also reveal the presence of black holes that are otherwise invisible, such as those in binary star systems or in the centers of galaxies. Black holes also produce gravitational waves, which are ripples in spacetime caused by the movement or collision of massive objects, such as black holes. Gravitational waves carry information about the sources that created them and can be detected by special instruments on Earth or in space. Gravitational waves were first predicted by Albert Einstein in 1916 and first detected in 2015 by the LIGO experiment, which confirmed one of the predictions of general relativity. Gravitational waves can help us understand more about the nature and origin of black holes and other exotic phenomena in the universe. According to the web search results, the nearest known black hole to Earth is Gaia BH1, which was discovered in September 2022 by a team led by Kareem El-Badri. Gaia BH1 is 1,560 light-years away from Earth in the direction of the constellation Ophiuchus and is roughly 10 times more massive than our Sun. However, It is probably not the closest that exists, or even the closest we will ever find, as astronomers think there are about 100 million black holes in the Milky Way, but almost all of them are invisible. Gaia BH1 is not dangerous for our universe, or even for our planet. It is too far away to have any significant gravitational influence on us, and it does not emit any harmful radiation that could reach us. In fact, there is no danger of the Earth, located 26,000 light-years away from the Milky Way's black hole, being pulled in by any black hole. Future galaxy collisions will cause black holes to grow in size, for example by merging of two black holes, but this will not affect our solar system. Black holes are very fascinating and mysterious phenomena, but they are not a threat to life as we know it. Within a black hole there's something called a singularity. A singularity is what all the matter in a black hole gets crushed into. Some people talk about it as a point of infinite density at the center of the black hole, but that's probably wrong. True, it's what classical physics tells us is there. But the singularity is also where classical physics breaks down, so we shouldn't trust what it says here. In a very specific mathematical case, the singularity in a spinning black hole becomes a ring, not a point. But that mathematical situation won't exist in reality. Others say that the singularity is actually a whole surface inside the event horizon. We just don't know. It could be that, in real black holes, singularities don't even exist. Some physicists have proposed alternative theories to explain what is inside a black hole. One of them is called string theory or M theory, which tries to unify quantum and classical physics by describing everything in terms of tiny vibrating strings. String theory suggests that black holes could be wormholes leading to other universes or dimensions. A wormhole is a warp in the fabric of spacetime that connects one place to another. If you imagine the universe as a two-dimensional sheet, you can picture a wormhole as a throat, connecting our sheet to another one. In this scenario, the other sheet could be a universe of its own, with its own stars, galaxies and planets. However, this idea is very speculative and has not been tested or confirmed by any observations or experiments. There are many problems and challenges with this theory, such as how wormholes would form in the first place, how they would be stable enough to allow travel through them, and how they would avoid violating the laws of thermodynamics and causality. Moreover, even if wormholes exist inside black holes, they would not be very useful for interdimensional travel, because anything that falls into a black hole would be stretched and torn apart by the extreme gravity and tidal forces before reaching the wormhole. Therefore, we do not have a definitive answer to what is inside a black hole or whether it is a portal to go somewhere else. It is one of the greatest mysteries of science and one that requires new theories and experiments to solve.
If you liked this video, please subscribe to the channel and give a thumbs up. Thank you.